Sometimes we're going to be given problems where we know the probability, but we don't know the x-axis value. So in this case, probability that x is less than or equal to a is 0.3. So I know that's going to be to the left of my mean. We're given a mean here of 2, and this is our variance, so our standard deviation must be square root of a half. So let's go ahead and draw in where we think a is. So it's about 0.3, so I'm going to put my a around here. And I know that this area is 0.3. Well, if I know an area shaded to the left, then I can come into my calculator and do an inverse norm calculation. So in my distributions, that's number 3. My area is 0.3. My mean was 2. My standard deviation is square root of 0.5. I'm anticipating my a value to be less than 2. And sure enough, a is about 1.63. Right, in this scenario, we want the probability that x is between 2 minus b and 2 plus b. Well, remember, 2 is our mean. So 2 minus b is going to be something over here. And then I'll have exactly the same height on the other side because it's 2 minus b, 2 plus b. So this distance here must be my distance b. And so we've got something symmetric. I know that this area is 0.48. So my remaining area must be 0.52. And then it's symmetric, so this must be half of 0.52, so 0.26 must be on this side, 0.26 on this side. Altogether, we'd have 100%. So I can do inverse norm of 0.26, so the probability that x is less than 2 minus b is equal to 0.26. And I just want to make sure I've done all those calculations in my head correctly. So, yeah. Okay, good. I'm going to inverse norm that. So I'm going to expect it to be even less than my 1.63 because I have an area smaller than the 0.3. So when I go ahead and do this calculation, I get 1.545. So that's my 2 minus b. So then I can calculate my b value, and it's going to be approximately equal to 0.4 or so, 0.455.